We have uncovered wonders undreamt by our ancestors who first speculated on the nature of those wandering lights in the night sky. We've crossed the solar system and sent ships to the stars. But we continue to search. We can't help it. A central element of the human future lies far beyond the Earth. Some cosmic purpose, then let us find ourselves a worthy goal.
Standing by for terminal count.
À tous de DDO, attention pour les décomptes finales. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top.
And we have engine start. And liftoff.
Décollage.
Décollage, liftoff from a tropical rainforest to the edge of time itself. James Webb begins a voyage back to the birth of the universe. Punching a hole through the clouds, 20 seconds into the flight, good pitch program reported.
Trajectoire est nominale.
The Webb telescope is finally on its way, the result of years of study and development by thousands of team members in the United States, Canada, and Europe. Webb's spacecraft ascends nearly vertically through the heavy lower atmosphere of Earth. As the rocket reaches maximum acceleration, the spent solid rocket motors are jettisoned safely into the Atlantic Ocean. Reaching the upper atmosphere where protection is no longer needed, the payload fairing is jettisoned and falls away. Accelerating through the atmosphere, the Ariane 5 rocket's first stage expends its fuel and shuts down. The empty first stage then separates from the upper stage. After first stage separation and before second stage ignition, the Webb telescope has a slightly downward trajectory as it speeds over the Atlantic Ocean. The upper stage motor ignites and the ascent to L2 resumes, never again to be interrupted. The exposed telescope is delicate and must be protected from the sun's fierce heat. To avoid overheating and damage, a carefully designed series of oscillations are performed that provide the necessary protection. Near the end of powered flight, the roll program stops and the launcher then assumes the proper attitude for separation. After separation from the Ariane upper stage, the Webb telescope continues its journey to L2 under its own power, taking the next step to its final orbital station 1 million miles from Earth. The Webb telescope is about to unleash a new dawn of discovery. The Webb telescope separates from the launcher's second stage. The white ring close to the Earth represents the Hubble Space Telescope's orbit. And the larger orbit is the geosynchronous orbit where most telecommunications satellites are located. The solar array is Webb's first deployment. When completed, all of Webb's electrical power needs are satisfied by the solar array for the remainder of the mission. The onboard control system continually monitors and updates the attitude to ensure power generation and thermal safety. To preserve the cleanliness of the mirrors, thrusters are located only on the sunlit side of the observatory. The trajectory is designed without employing a retrofire, which necessitates pointing the delicate telescope at the sun. If course corrections are needed, these velocity additions must be done early in the flight to most efficiently use the mission's limited precious fuel. After completing mid-course corrections, the Webb telescope passes the orbit of the Moon. Webb's initial transformation is the deployment of the sun shield pallets. The tower separating the telescope and instruments from the spacecraft and sunshield is next. Next, the aft flap deploys. This is key to managing momentum buildup and fuel consumption. This structure helps to balance the pressure from the sun's light on the Webb telescope around its center of mass. After the sunshield pallets reach their final positions, the membrane launch restraints are released. These have kept the sunshield membrane safely in place from final stowage at the Northrop Grumman facility in California through shipment and launch. The sunshield protective covers roll back, permitting membrane deployment. The covers over the core region release next. Then the mid-booms extend and the sun shield assumes its hexagonal tennis court-sized shape. It is now time to tension the sunshield membranes, each thinner than a human hair, pulling each of the uniquely sized and shaped layers to their optimal position. When deployed, the sunshield allows the telescope to cool to 385 degrees Fahrenheit below zero, cold enough to liquefy air, while the layer closest to the sun is almost 190 degrees Fahrenheit above zero, nearly the boiling point of water. It's at almost 600 degrees. Truly fire and ice. Once in the shadow of the deployment, Sun, Earth, and Moon, the brightest objects in the
Get ready for the most spectacular images ever created. Today, NASA's James Webb Space Telescope amazes us with its new views of the universe, but its images build upon 40 years of innovation and infrared space telescopes. The universe is full of infrared light at wavelengths much longer than what human eyes can see. We need space telescopes equipped with special detectors to reveal these hidden wonders. The first was the Infrared Astronomical Satellite, or IRAS, launched in 1983, measuring the infrared glow of hundreds of thousands of stars and galaxies. In 2003, the Spitzer Space Telescope began a new era of infrared astronomy. Spitzer revealed the tale of galaxies and nebulas never seen before. Now Webb takes us even deeper into the infrared universe. We look forward to the wonders yet to be revealed by Webb and future infrared telescopes. What you're about to see cost humanity $10 billion and 30 years to capture. These aren't just photographs. They're windows into the birth of the universe itself. Welcome to James Webb's greatest discoveries. Meet Able S1063, a monster galaxy cluster sitting 4.5 billion light-years away that's acting like a cosmic magnifying glass. This gravitational giant is so massive it bends light from distant galaxies behind it, creating those stunning warped arcs you see stretching across the image. Each glowing streak is actually an entire galaxy from the universe's distant past, twisted and magnified by the cluster's incredible gravity. Hubble discovered this cosmic lens first, but Webb's infrared vision is revealing a whole forest of these distorted galaxies we've never seen before. It's like having a telescope that can see through time itself, using the universe's own gravity as our lens. Deep in the constellation Scorpius, 4,000 light-years from Earth, massive young stars are carving through gas and dust like cosmic sculptors. The chaotic stellar nursery won't last forever. These bright giants will eventually destroy their own birthplace. This is M82, a galaxy that completely defies expectations. Despite being smaller than our own Milky Way, this cosmic beast shines 5 times brighter and cranks out new stars at 10 times the rate of our home galaxy. Scientists call it a starburst galaxy because it's forming stars way faster than it should for something its size. For years, thick clouds of dust hid the intense action happening at its core from our view. But James Webb's infrared vision cuts right through that cosmic fog, revealing the incredible stellar factory hidden at the heart of this galactic overachiever. Watch as 2 massive galaxy clusters collide in the ultimate cosmic crash. That beautiful blue spiral galaxy sits right in the middle of the gravitational battlefield. Webb's incredible precision revealed dozens of distant galaxies hidden in the chaotic scene, helping scientists measure the true power of these colliding giants. A dying star's final masterpiece unfolds before our eyes in unprecedented detail. Those intricate rings aren't smooth. They're actually clumps of dust and gas blown out by the star's last breath. Notice those dark holes punched through the bright pink center. We've never seen them clearly before. Witness a baby star throwing the ultimate cosmic tantrum. Young stars are blasting jets of material at incredible speeds, carving through space like a cosmic speedboat cutting through water. Those reddish arcs show where the jet slams into surrounding gas and dust, heating it up and making it glow. By pure chance, there's a distant spiral galaxy perfectly aligned at the tip of the stellar outburst, creating one of the most spectacular cosmic coincidences ever captured. 650 light-years away in the constellation Serpens, two baby stars are putting on a spectacular light show. Those shimmering ejections are jets of material blasting out from the forming stars, creating incredible asymmetrical patterns that seem to dance and collide with each other. Webb's infrared vision reveals structures so detailed, it's like watching stellar birth in high definition. Welcome to the cosmic crime scene of IC 2163 and NGC 2207, two galaxies that collided millions of years ago and are still dealing with the aftermath. That gruesome red palette isn't blood. It's the combined light from Webb and Hubble revealing the chaos of their encounter. The galactic survivors are now cranking out stars at an incredible rate. 24 new suns every year compared to our Milky Way's measly 2 or 3. 7 massive supernovae have already exploded in these galaxies, clearing space and triggering even more star formation in those bright blue regions. One galaxy, two completely different faces depending on how you see it. The top left shows Hubble's view invisible light, where thick dust lanes appear dark and block our view. But flip to Webb's infrared vision on the bottom right, and those same dust lanes light up like cosmic highways, glowing with warmth. It's the same galaxy, but Webb sees the heat that dust gives off after absorbing starlight, revealing hidden structures Hubble could never show us. Imagine a world where a year lasts just 23 hours and temperatures reach 2,700 degrees Celsius. WASP-18b is an extreme world that makes Jupiter look tiny, 10 times more massive but racing around its star faster than Earth spins once. Webb detected water vapor in its scorching atmosphere, where one side always faces the star while the other stays in eternal darkness, creating a temperature difference of over 500 degrees across its surface. What looks like moonlit mountains is actually one of the most violent stellar nurseries in our galaxy. These are the cosmic cliffs in the Carina Nebula, where massive young stars are literally carving away at their surroundings with intense radiation and stellar winds. That dramatic cliff edge is the wall of a gigantic gas cavity, slowly being eroded by the incredible energy of newborn giants hidden just above this view. Webb's infrared vision cuts through the cosmic dust to reveal hundreds of stars that were completely invisible before, turning this stellar graveyard into a treasure trove of discovery. Behold M74, a galaxy so perfect it looks like it came from a textbook. Located 32 million light-years away, the grand design spiral shows us what textbook galaxies actually look like, with crisp, well-defined arms that spiral outward in mathematical precision. Webb's incredible resolution reveals delicate filaments of gas and dust threading through those majestic arms, while the clear nuclear region gives us an unobstructed view straight into the galaxy's heart. It's sitting almost face-on to us, making it the perfect laboratory for studying how spiral galaxies actually work. The most famous star nursery in the universe just received the ultimate makeover. By combining Webb's near and mid-infrared cameras, we're seeing the pillars of creation like never before. ablaze with thousands of newly formed stars that appear as bright orange spheres bursting from the pillar edges. Those towering columns aren't empty. They're packed with dense dust and gas collapsing under their own gravity to birth new stars. The orange dust draping across the top and the deep indigo regions show us the raw materials of stellar creation, while stars practically burst onto the scene at the pillar tips. Every photon of light in these images traveled billions of years just to reach us. Each galaxy, each star, each swirling nebula represents countless worlds and infinite possibilities scattered across the cosmos. James Webb isn't just showing us space, it's revealing our cosmic family tree, proving that we're all made of stardust from these very same stellar nurseries. The universe is vast, beautiful, and full of wonders we're only beginning to discover. And this is just the beginning. Thanks for watching. Subscribe now and keep looking up to the stars.